Good morning, everybody. Really nice to see you all here. I'm just going to do a simple introduction. It's William Weaver from Applied Graphene Materials who's going to talk to you about unlocking the potential of graphene, enabling technical advantages in industrial applications, from high-performance coatings to hydrogen storage. William, do you want to come up here?
So good morning, and thank you for the opportunity to present Applied Graphene Materials. Applied Graphene Materials is a leading global player in the graphene world, established back in 2010 as a spin-out from Durham University, and is headquartered at Wilton down at Redcar. Applied Graphene Materials produces graphene on site, but also has a technical capability. We have extensive laboratories and expend a significant amount of effort looking for applications for graphene. So if we move to what graphene is, you've all seen the hype over the last 10 years. You know that it has a significant amount in terms of its behavior characterized and significant claims made for it. The issue, though, has been for the last 10 years how to use it. Graphene loves itself. It tends to agglomerate. Once it agglomerates, it doesn't do anything. So dispersion has been key, and industry has, over the last few years, recognized that that is the critical step in getting graphene to work and being able to realize its potential. So, moving on. Graphene, as I said, is extremely difficult to disperse. Applied Graphene Materials has spent significant effort unlocking that problem. Today, we have our own in-house technology, patented, which enables us to produce a whole range of dispersions. We were the first company globally to produce a standard range of dispersions. And we have in-house the capability to produce bespoke dispersions through our innovative service capability and contract, which enables us to take something which a company is looking at, but is unsure would fit with our existing dispersions, and develop something totally new, bespoke for them. Graphene has a broad number of applications. Over the past 10 years, you'd have struggled not to open a newspaper and see something new. And this is very much a technology which is seeing application in a whole broad range of industries, such as transportation, infrastructure, aerospace, etc. The key, though, has been, as I said, that dispersion and realizing it. And I'm pleased to say that finally, after much effort, we're actually seeing some pull-through in terms of the use of graphene commercially. Those dispersions which we've actually developed are coming forward in terms of practical, real-time applications. But most of those, I have to say, are in coatings. And I'd like to spend a little bit of time on coatings and really what they are important for, and why putting graphene into coatings is significant. So, we all use infrastructure, we look at it, we use it every day. In most instances, it is protected. It's protected by a paint, which most people don't pay much attention to. But in actual fact, that is really liquid engineering. We're talking about a coating of a few microns thick protecting a substrate. Protecting it from corrosion is critical in terms of maintaining its serviceability and its safety. Protecting it in terms of cost is also important. Back in 2013, the calculation was done that it was something like $2.3 trillion worth of impact in terms of corrosion cost, which amounted to about 3.4% of global GDP. This cost is significant, and it causes significant disruption not only to us as people walking about, crossing the Tyne Bridge, whatever, but also within industry as we have to take facilities out of service. Graphene has been shown to really support and prevent corrosion resistance. We can retard the onset of corrosion very significantly. In a similar way, we can also reduce the impact of chemical resistance. So if you have a facility where you're handling a very corrosive material, you do not want that facility to go out of service. We live in a supply-constrained world at the moment. Taking a facility out for essential maintenance is the last thing we want to do, and it's unlikely to change. So, in two respects, where graphene is going into coatings, we have an essential role to play in terms of enhancing technology and bringing key performance benefits. AGM have significantly developed the data to support that understanding of corrosion performance and chemical resistance, and moved forward recently to offer two primer systems, which are going into use. We're currently working with the Environmental Agency to actually coat coastal defense, flood defense systems, protect them from corrosion, and it is very much seen as a move towards improved sustainability. The sustainability performance comes not only from ensuring that those floodgates are operational in a consistent fashion, but also if we can extend the period of refurbishment, we reduce the amount of raw materials being used, but critically, when we're refurbishing those structures, that infrastructure, we're removing the old paint. That creates microplastics, which gets into the environment. The amount of microplastics which are generated from paints in the North Sea is extremely significant, and this is a key step. Not only are we reducing microplastics, but potentially also other heavy metals which are currently being used in coatings to reduce corrosion. Other areas that we're seeing application of these primer systems is in terms of roofing systems. Large open spaces, often not seen, where corrosion can occur and rapidly build up. At the same time, we're also seeing infrastructure such as the cladding and that's associated with, for instance, telecommunication towers, where, again, it's not very often visited, it's not maintained generally on a day-to-day basis, but corrosion, if it occurs, can take something out of service and have quite a significant impact. So, chemical resistance. Chemical resistance is not only about steel and pipes, it's also about concrete. It's also about a whole range of applications in terms of the infrastructure, but also transportation. And these are areas where we have just released some new data demonstrating the improvements that graphene can deliver. And with that, we hope that we'll be able to make some significant contributions to the build-up of the infrastructure that is associated with the building of, for instance, and handling of materials such as lithium. So areas where there are new corrosive environments which we're generating, and much of what we're doing in addressing net zero is taking us into new spaces where we don't fully appreciate the full nature of how we can handle things, how we will store things, is important. And graphene potentially could create a new solution for us. In terms of other areas, hydrogen was mentioned. AGM has collaborated with a partner company in the United States, Infinite Composites. They have been combining graphene to deliver not only the barrier properties that are associated with the work that we've done on coatings, but also the mechanical properties of graphene. They've combined those in a carbon fiber composite in order to develop high pressure, low weight pressure vessels. These have been validated by NASA and are currently being looked at for use in the latest set of satellites that are being considered. But there are also clear potential for use of this technology in the hydrogen space. We need lightweight, strong, reliable vessels to carry hydrogen if we're going to be successful. And this technology is now being investigated and taken forward in a number of different areas, both in aerospace as well as automotive, together with the more general supply areas. AGM is working across the board in the technologies for net zero. We're collaborating with several local universities, and we have a range of projects, PhD programs, where we're looking to explore and develop the use of graphene in materials ranging from wind turbine blades right the way through to thermal management systems for batteries. And if you have thoughts or ideas in that respect, please come and talk to us, because we have both a capability internally but also a strong network externally for the use of these materials, and can bring that to bear, hopefully, in collaboration. Sustainability. Sustainability goes alongside net zero. I've already indicated for coatings that, okay, there are sustainability advantages being seen in terms of the coatings, protection of infrastructure, reduction of the need for maintenance, extension of that maintenance period and reduction of materials used, release of toxic materials and microplastics. But you need to take that further forward. So one of the things we've done recently is introduce new dispersions. We have dispersions based on bio-based resins. We've got water-based dispersions, which take us into the region of which we remove essentially any of the solvent materials that are being used in many applications. And we've also got extremely low viscosity, high solids dispersions, which enable us to work across a number of different formulations without a negative impact. So these are areas that we can support, and with the internal capabilities of AGM, we have, as I said, an extensive range of test facilities and the capability to carry out bespoke formulation. We can, I think, support any new requirements in the dispersion field. Why AGM? Why collaborate? Why consider graphene? Graphene is something which has had a lot of hype. It's also perhaps not been something that has delivered immediate return. But at the same time, I think, and I hope, you can see that in some areas, it's beginning to show its promise. It's beginning to deliver. AGM has the ability, through its technical support, through its resource and its knowledge, particularly around dispersion, to deliver technology for use in a broad range of application areas. Our dispersions are easy, safe to use, and we're ready and able to support collaboration, both at a company level, but also with universities in the development of new technologies. So, thank you for listening. I'm here for today. My colleague David Blaine, our CFO, is here today. If you have any interest or thoughts as to potential applications, we are upstairs. Please come and see us and talk to us about how you would like to collaborate. Thank you.
I'd just like to open up, if anybody's got any questions that they would like to ask William, that we've got 5 or 10 minutes before the coffee break. So, gentleman here, you've got a question you'd like to ask?
Just a quick question. What's the circular economy? What happens at end of life with graphene? So if we must have ones who actually have their issues in terms of reusing them, breaking them down, recycling. Adding a graphene coating, is that going to cause problems?
Okay, so the circular economy is quite challenging in terms of a coating. Trying to recover something that's maybe only 100 microns thick is not something that's easy. There are areas where people are looking at depolymerizing coatings, and there's some new developments in that space which would allow you to take a coating off and recover something, but it's probably at this stage not something I would expect to see in the next 5 years, perhaps even 10. Because those coatings have some significant challenges in terms of if you're going to recycle something in that fashion, often the conditions that you can recycle it in actually affect its performance in service. So there's some significant scientific hurdles to overcome. The bigger question is, does graphene have an adverse effect on the environment? And there's quite a bit of research coming out at the present moment in time, both from the graphene flagship but in other areas, showing that graphene and when it's incorporated into a coating, doesn't actually have an adverse effect on ecosystems or indeed have any adverse human toxicology effects. So in that respect, it's not having an adverse impact, but in terms of being able to recycle it, that's a question which is some way away, and it's really tied up to the chemistry of the matrix that it's embedded in.
Can I just ask you, where do you actually find graphene and how do you extract it?
Okay, so graphene comes from a number of different sources. So graphene, as we handle it, is synthetic. So we take a basic alcohol and we process that into graphene. You can also obtain graphene by exfoliation of graphite, which is the traditional way of obtaining graphene. So the vast bulk of graphene that you'll see in the market is obtained from graphite.
How much graphite do you need and where do you source that from?
Currently, our main source is synthetic. So at Wilton, we have a plant and we make a biosynthetic route. We also have the ability to make dispersions on exfoliated graphite, which we're sourcing from a number of different locations, typically places like Sri Lanka and Australia, but also in the US. Okay. It's a very interesting question because the properties are very different. Sure. Okay. So when you exfoliate graphite, you end up with a morphology which is very flat, planar. Depending on how you synthesize it, you can actually create morphologies which are folded, buckled, or curved. Now, you also check a key aspect of graphene's performance is the thickness, and with the thickness, the modulus variation. And by playing with those two, when you exfoliate or you synthesize, you get different properties. So I think there's space for both, in all honesty. And in truth, I mean, I think if we look at the balance, I mean, you've got to look at the energy input from both and look at the life cycle analysis as to which one would have a significant benefit over the other in that respect. At the moment, I think they're balanced.
That's a very interesting answer because there's a number of raw materials that are going into the chemical industry where there's a shortage of mined raw materials, and the obvious is to use synthetic raw materials, and time again the answer is balance of both.
Any more questions? Mark?
Can you tell us a bit more about, is there any fire-resistant properties of introducing graphene into materials?
Okay, introduction of graphite has a clear benefit in terms of fire properties. As yet, introduction of graphene is, I would say, not quite proven. We have seen benefits, not in terms of fire performance per se. So changing rate of spread of flame, for instance, but changing the nature of the char that's residual, which is really important if you're looking at structural integrity. Yes, we do see changes. And I think there is some interesting work in the future to be done in that space.